Greetings Year 9 and welcome to the continuation of our exciting lessons on trigonometry. Today we're going to be solving trigonometry questions where we actually have to find an unknown side that's part of a denominator. Now let's just remember SOHCAHTOA, sine equals opposite over hypotenuse, our formulas. Cos theta equals adjacent over hypotenuse. Tan theta equals opposite over adjacent. So we need to make sure we're aware of our formulas. Let's get into it. Now before we do any trigonometry questions, let's just do an algebra question. 3 is equal to 7 over x. And let's solve for x. So the first thing we notice is that there's x on the bottom of the fraction. So let's times both sides by x, because doing that will get rid of the fraction. And timesing both sides by x means on the right hand side our x's cancel. It's really important that you understand that when you're timesing by x, you're actually timesing by x over 1. So the x must be on the top of both sides, not on the bottom of the fraction. That's what allows you to do the cancellation. So when we times both sides by x, we get x times 3, which is 3x equals 7. Now we can divide both sides by 3, which means you get x equals 7 over 3. Now let's just compare the original question, 3 equals 7 over x, to the answer, x equals 7 over 3. And can you see something a bit weird there? Can you see that the 3 and the x have just really switched positions? Let's just try that once more to see what happens. So let's try a different question. 5 equals 3 over a. Well, to do a question like this, we're going to times both sides by a, because a is on the bottom of the fraction. And when you do times both sides by a, you go, oh, those a's cancel, which leaves me on the left with 5a and on the right with 3. Then we'll divide both sides by 5 and we'll end up with a equals 3 over 5. Let's compare the original, which was 5 equals, whoops, better write that properly, 5 equals 3 over a. That was the original question, and our answer was a equals 3 over 5. Well, what do you notice between the original question and the answer? If you swap the 5 and the a around, you get the answer. A to there, 5 to there, a equals 3 over 5. So what actually happens when you're dealing with one fraction, so let's just see if we can shortcut this. If I had a fraction, let's say I had 11 over m. When I'm dealing with a fraction, and the unknown letter that you're looking for is on the bottom of the fraction, if that's equal to some number, then the easy thing is to play what I'm going to call switchies. We'll switch the m and the 5, and there's our answer. If you want to go through the process where you times both sides and divide both sides, that's fine. But that's called switchies. And so we'll play that. So let's have a look at part B. Oh, hang on now. Can we recognize here that the sine of 60 degrees is equal to 8 over x, and the x is on the bottom of the fraction. So it's in the denominator. And when you get the unknown on the bottom of the fraction, we're going to play switchies. But let's just do it the long way to make sure it works, and we'll play switchies from then on. So let's times both sides by x, because there's an x on the bottom of the fraction, and when we do that, that x on the bottom of the fraction cancels with the x you multiplied by. So you end up with x times sine 60 equals 8. The whole idea or the purpose is to solve for x, to get x by itself. X is being multiplied by the sine of 60, and the way you undo multiplying by sine 60 is divide both sides by sine 60. The sine 60s will cancel on the left side, and you'll end up with x equals 8 over sine 60. which you can put into your calculator, and it's 9.24 to 2 decimal places. But let's just focus for a second. The original question was sine 60 degrees equals 8 over x. And when we worked our way through the question, what would have happened if we just played switchies and swapped the sine 60 and the x? We would have ended up with x equals 8 over sine 60. So to save multiplying both sides and dividing both sides and to shortcut this process, whenever we have a question where the letter we're looking for is on the bottom of the fraction, a trigonometry question like these, we're going to play the switchy game. So let's try it. Solve for x in the following equation here. Tan 45 equals 10 over x. X is on the bottom of the fraction, so we're going to play the switchy game. So we're going to switch the x and the tan 45, which means x is 10 over tan 45. Put that into your calculator, and you end up with 10. Let's try it again. Oh, we're looking for an x that's on the bottom of the fraction, so let's play switchies. So we switch the x and the cos 10, x equals 3 over cos 10. Put that into your calculator, x is equal to 3.05 if we round it to 2 decimal places. Let's try another one, except this time we've got to create the equation. Now, we remember our formulas, SOHCAHTOA, because it tells us what the formulas are for sine, cos and tan. Let's look at our question here. The angle we're dealing with is 38 degrees. What are the sides? The side that x is on is the longest side, hypotenuse, and this is next to the angle, so it's the adjacent side. What formula uses adjacent and hypotenuse, A and H? Cos. So we write down our formula. Cos theta is adjacent on hypotenuse. Cos 38 equals 12 over x. And now look at the question. We're trying to get x by itself, and x is on the bottom of the fraction. When x is on the bottom of the fraction, we play switchies. Let's switch them and put that into the calculator, and x will equal 15.23 if we round it to 2 decimal places. Let's label our triangle for part B. We know the angle that we've been given is 26 degrees. So what's x and what's 11? Well, 11 is the opposite side, x is the adjacent side, opposite and adjacent. Use tan. So we write down the formula for tan. Tan theta is opposite over adjacent, TOA. Tan 26 will be 11 over x. And now look at this question. The x is on the bottom of the fraction. This switchy method only works if x is on the bottom of the fraction. So we're going to play switches. Switch the x and the tan 26 and you get x equals 11 over tan 26, which when you put it into your calculator will give you 22.55 to 2 decimal places. So try doing part C by yourself and see how you go. I'll wait about 15 or 20 seconds. Go. And so now I've put the answer on the screen. So with our 20-degree angle, we had the opposite and the hypotenuse, which made it a sine question. So sine 20 is 15 over x. X is on the bottom. Let's play switchies. So x is 15 over sine 20, or 43.86 if we round that to 2 decimal places. Now the last question, or for example 2, part D, we just need to be aware of, we're not given any angles, but we know with this question that it's an isosceles triangle because we're given those two sides are the same length. Now you could use Pythagoras' theorem or you could use trigonometry, but to use trigonometry you need to know that these two angles are 45-degree angles. Why are they 45-degree angles? Because if it's isosceles and this one's 90, all triangles have three angles that add up to give 180. If that's 90, these two have to be the same. 45 and 45 give 90. And that's another 90 to make 180. Why do they have to be the same? Because it's an isosceles triangle. And isosceles triangles have two sides the same and their base angles are the same. So, if we wanted to, we could actually look at the angle down the bottom here. You could have chosen the angle at the top. That's okay. It would have labelled things differently. And if that's the case, you could use this side here and this side here, and you'd have opposite over hypotenuse. You could have also used this side here and this side here, and you would get the same answer. It's okay. Doesn't matter which way you do it. So using my 45 degrees here and opposite and hypotenuse, it's a sine question because sine is opposite over hypotenuse. Sine of 45 degrees is 4 over x, but the x is on the bottom. So we're going to play switchies. Switch the x and the sine 45. And you get x equals 4 over sine 45, which is 5.66. Have a look at how else that question could have been done. I could have gone x equals the square root of 4 squared plus 4 squared. Put that into my calculator, and when I put that into my calculator, you will get 5.66 if you round it to 2 decimal places. So that's actually faster than using trigonometry because we were given two sides and we were trying to find the third side. So trigonometry would have been a slower method than Pythagoras' theorem for this example. Well, time for you to try doing some questions. Enjoy the experience. Bye for now.